Hey, algebra. So one more stop along our journey of pre-algebra review is with fractions. We're going to look at dividing, right? So we've seen multiplying. We look at dividing fractions. All right. So let's start off with your favorite number. You know, that's an intensely personal decision, but mine is 12. We've got this flag actually hanging in the classroom, and you may not be able to see it right now, but we're going to work with the number 12. So if you take your 12, we multiply, we're going to do multiplication and division. I know it's not a fraction, but if we multiply by 3, that means we need 3 groups, right, of 12, right? So 12 plus 12 plus 12. Okay. We talked about multiplication, and we're supposed to be studying fractions. It's not even a fraction, right? It's the concept of multiplication is the same, whether we're using fractions or whole numbers. It just means multiplication means groups, right? So what about dividing? If I took our favorite number 12 and I divided it by 3, then that means we're splitting it into parts, right? So if I had 12 little blocks, so just as an illustration, if I have 12 little blocks, each one is worth 1. If I divide that into 3 parts, then three even parts, then each block's going to have, each group is going to have 4 blocks in it, right? So I got 1 group, 2 groups, 3 groups. I took 12, I split it into 3 groups. Okay, so that means if I took all of those pieces, even after I split it into parts, that represents the whole, right? And another way of looking at division is to say, whoops, that's too much. Okay, is to say, if I had 12, I can write it with the line, which makes it kind of look like a fraction. And then we get this artificial distinction of like, well, that's a fraction, not division. But really, fractions and division are the same thing. We put a different label onto it. We use it in maybe sometimes different contexts. Really, it means the same thing. A fraction is just division that's been applied into a special context. Okay, so 12 divided by 3, right? That means I can take the 12, split it into 3 parts. A different way I could explain that same idea is if I look just at is 12 times 1/3, right? Division is like the inverse of multiplication. Multiplication is the inverse of division. They're like opposites, opposite operations. It's an opposite process. One does, the other undoes. Doesn't actually matter which one you start with, right? So if I had 12 times 1/3, so you had like the division line, the fraction line with the 3 on the bottom, and so here's my little fraction line with the 3 on the bottom. Over here, I had the 12 on the top part. Over here, 12 is like off on the side. But if I thought about what would happen if I took 12 as a whole number and multiplied it by 1/3, the 12 is going to multiply onto the top, 12 times 1, which would just be 12, which is the same thing. Okay, so the bottom number of the fraction, the denominator, tells me how many parts it takes to make one complete whole, right? It takes 3 parts to make one complete whole. I have one of those parts. That's what the numerator tells me, right? The denominator is how much it takes to make a whole. The numerator is what number of those parts do you have? Okay, so I'm going to take that fraction and apply it to the whole number 12. Okay, so if I have 12, right? It takes 3. So I'm going to work backwards through these 3 little illustrative explanations. Okay, so I'm going to apply the concept to the number 12. So here's a representation of 12, an illustration. It takes 3 parts to make one complete whole. So I'm going to break this apart into 3 parts. It takes all 3 of those to make one complete whole. But in this case, I only have one of them, right? So even though I had those to make a complete whole, I don't have a complete whole. I just have one of the parts. And starting from the original 12 blocks, when I split it into 3 groups, each of the groups got 4, and now I've only got one of these little parts, right? So 4. 12 divided by 3 equals 4. We knew that all along. Okay, the point was not to convince you that the answer is 4. The point is to hopefully make sense of some of the reasoning why, when we say to divide by fractions, we don't actually end up dividing. Um, right? That's the tricky part about dividing by fractions. Okay, so I've given away. There's the secret of the lesson. When we divide fractions, we don't actually divide. We take a division problem. We're going to turn it into multiplication, but some changes have to happen along the way. So here they are. In order to divide a fraction, if I have a fraction divided by another fraction, I'm going to take the reciprocal of the second fraction. Okay, reciprocal is a fancy math word that means basically to flip, and it doesn't mean flip, but that's the way we think about it. You take that second fraction, we're going to flip it upside down to create the inverse of the division problem. Okay, so flip the second fraction. You can't flip the first fraction, that won't work. You'll get the wrong answer. You have to flip the second fraction. Then we multiply straight across, top times top, bottom times bottom, and finally always reduce if possible. Okay, so let's look at some examples. I know you listened to me explain about why dividing works this way, and maybe you don't even care. You just want to know how to do it, right? So the second fraction, 7/8. That's the one we're going to have to do the reciprocal of. So this problem is going to turn into 3/4. That part doesn't turn into anything. 3/4 stays the same. That's the first fraction. The second one I'm going to flip. So instead of 7/8, it's going to be 8/7. And now, instead of writing this as a division problem, it's going to be a multiplication problem, right? Okay, so multiply straight across the tops. Top times top, that'll be 3 times 8. And bottom times bottom. Oh no, oh, it's not blue. Shoot, well, maybe it will let me move this. Let me just get rid of that thing. Sorry, okay, there we go. So now I can go to a new line because I don't have enough room. There's my fraction line. Okay, so on the top, 3 times 8, that's 24. On the bottom, 4 times 7, that's 28. All right, so I have completed the division. I rewrote the division as a multiplication problem by flipping the second fraction and multiplied straight across the top, straight across the bottom. Bland. Answer. Yay, except I always have to reduce when possible. This one you can reduce. I remember both of these two numbers show up in my times tables under 4s. I know 4 goes into 24, and I know 4 also goes into 28. All right, so I'm going to divide both of these numbers by 4 in order to simplify, because I remember that they both show up in that row of my times tables. Let's move this equal sign out of the way. That's too close. Okay, and then, whoops, turn the pen back on. Pen, 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 pen. There it is. All right, so 24 divided by 4, let's get our new top number. That's going to be 6. And on the bottom, 28 divided by 4, that's going to be 7. Okay, 6 and 7, I cannot reduce anymore. I know that for a fact because 7 is a prime number, meaning the only things that multiply into 7 are 1 and 7. So I cannot reduce this fraction anymore. All right, so we're going to circle this one with stars. Yay, star. Nice work. Okay, let's take a look at one more example. Whoops, that's too far. All right, so here's another example, 5/12 divided by 5/2. All right, so I need to start by flipping that second fraction. Okay, so this problem, I'm going to rewrite it. It's going to be 5/12. And the second fraction is going to be 2 on the top, 5 on the bottom. So I switch places. And now this will be a multiplication problem. Okay, so I've rewritten the division as multiplication. Now I get to multiply straight across the top times the top and straight across the bottom times the bottom. Before I actually do that, though, I noticed something. I notice that I have a 5 here on the top of one fraction. I also have that same number here on the bottom of a fraction. So I'm going to save myself a little bit of time so I don't have to reduce as much later. I'm going to do a thing called cross canceling. So it's not a requirement. You could just multiply 5 times 2 to get 10, and on the bottom, 12 times 5 to get 60, and then you could reduce the fraction. That's totally fine. We're going to end up at the same place after you finish reducing, but just to save a little bit of work. Since these are both the exact same number, I can think about it. I should explain instead of doing things mentally. I'm going to cancel them because 5 divided by 5 equals 1. Here's why that's possible. You normally would not write this out this way, but let's just think about it this way. So I'm going to multiply the top times the top, so that's 5 times 2. And I'm just going to write it as 5 times 2 instead of actually doing the multiplication. And then on the bottom, 12 times 5. When I multiply, it doesn't matter what order I multiply things by. So I could do 12 times 5. That's the exact same thing as 5 times 12. Just for the sake of making this illustration clearer, I'm going to switch the order so that I have the 5 first on both the numerator and the denominator. And then, let's see, I get a different color. Okay, so if I look just at the part of this problem that I've highlighted in pink, I have 5 on the top, 5 on the bottom. This line, I know it's a fraction line, but it means divide, right? And so I could do 5 divided by 5. I could do that first. I know that 5 divided by 5 is 1. And if I multiply anything times 1, just get itself, right? So basically, the pink part is going to make 1 multiplied by 2/12. And 2/12 multiplied by 1 is the same as just 2/12, right? So I can, without changing what this problem means, cancel, so to speak, the 5s. Okay, so that would leave me with 2 on the top and 12 on the bottom. I can also cancel those. I'm going to write it down first. And I could have canceled it ahead of time. If you see this, I could say, hey, look, this 2 and that 12, I can see that 2 goes into 12, and so I could do cross canceling. I could cancel out the 2 on the top here and say, well, 12 divided by that 2 to get it to cancel is going to be 6, right? Kind of the way I've written it, I'm really just reducing the fraction that's left. It's going to give me the same result, like I mentioned earlier. So I know that 2 goes into both 2 and 12. They're both evens. I can divide 2 in both cases. So my final answer is going to be, sorry, let me write down my work. So divide both the top and bottom by 2 to reduce it or to simplify it. Final answer is going to be 1/6. And we better get something awesome to circle this in. Let's see, how about stripes? Stripes are pretty awesome. Maybe. All right, cool. So that is the way that we can divide fractions. We can get some cross canceling to save some work in the steps, or we can just reduce at the end. Either way. All right, good.